Hello, everybody, and welcome to our conversation today. This is Mathematics for Human Flourishing, an interdisciplinary conversation. I'm Travis Pickell, and I'm the Associate Director of University Engagement at Anselm House, a Center for Christian Study at the University of Minnesota. Today's event is the result of a partnership between Anselm House and Upper House, a Center for Christian Study at the University of Wisconsin-Madison. Both Anselm House and Upper House exist to serve Christian students, faculty, and staff, and to advance Christian intellectual engagement in the context of large public land-grant universities. Over the past few years, our two organizations have partnered on a number of public events and faculty retreats and online forums, like the one that we're excited to host today. In his idea of the university, John Henry Newman argued that a university is, as reflected in its very name, is something that exists for the purpose of pursuing the unity of knowledge, by which he meant, I think, an integrated and holistic approach to academic inquiry. According to Newman, no field of legitimate study should be left out, and the various disciplines, as necessary as they are, must not proceed as if their own way of approach was fully sufficient for understanding truth. Both disciplinary silos and the modern tendency to bracket out religious and specifically theological concerns have had the unfortunate side effect of obscuring knowledge, both in its entirety and in its parts. Newman envisioned the university as a place where students would benefit, quote, by living amongst those and under those who represented the whole circle of knowledge, an assemblage of learned men, zealous for their own sciences and rivals of each other, are brought by familiar intercourse and for the sake of intellectual peace to adjust together the claims and relations of their respective subjects of investigation, to learn to respect, to consult, and to aid each other, end quote. So today's conversation aims to be one which, in the spirit of Newman's vision, is demonstrated. Here we bring insights from perspectives of multiple disciplines together in a way that also attends to broader questions of meaning, purpose, and transcendence. The relationship between mathematics and human flourishing, so eloquently described by Professor Su in his recent book on the topic, will be our focus. In conversation with Professor Su, we're excited to have Dan Hummel, Director of University Engagement at Upper House. Dan's a historian by training, having earned his PhD in history from University of Wisconsin-Madison. His first book, which came out in 2019, was called Covenant Brothers, Evangelicals, Jews, and U.S.-Israeli Relations, was published by the University of Pennsylvania Press. And he's at work on another book on the history of dispensational theology from Erdman's Press. His writing on history has appeared in the Washington Post and the Religious News Service. And we're really excited to have Dan converse with Francis Su. So at this point, I'd like to invite Dan on, who will introduce Francis and start our conversation together.
Hello, and welcome to this conversation with Francis Su. Francis Su is the Benedictson Karwa Professor of Mathematics at Harvey Mudd College. And he's also the author of the book we're going to talk about today, Mathematics for Human Flourishing, which came out with the University of Yale Press last year. And the last thing I want to mention about Francis before bringing him on screen is that he was the president of the Mathematics Association of America a few years ago. And so he is one of the foremost mathematicians in the country at work today. Welcome, Francis.
Thank you. Thanks for having me. It's great to be here.
Awesome. Well, I'm really excited to get into your book. I should set this up for the viewers that I am a historian, and I will sort of weigh in a few times here from the historical perspective, but I also want to try to represent a few other fields as well, art and sociology and a couple other ones. But what I found so enriching about your book and what I think will be really productive today is to just think about the very universal human desires and virtues that you talk about in your book from multiple perspectives. And as I mentioned, I'll bring some of that, but I also want to encourage viewers to use the chat function to ask questions yourself. We had a number of pre-submitted questions, and we'll get to those at the second half of our time here, but also would be very interested in people's live reactions and questions from multiple perspectives. So please use that chat function, and we'll try to get to as many questions as we can. So with that said, Francis, could you just set us up and give us a synopsis of Mathematics for Human Flourishing and a little about why you wrote the book?
Sure. Yeah. Thank you. So I guess one way you can think of my book is that it's a plea to change the way that we view ourselves by changing how we view mathematics. Viewing math not just as a collection of facts to learn, but as a set of practices that shape us and practices that connect to our deep human longings. And I attempt to do that in the book by telling lots of stories, including my own, but also that of Simone Weil, who's some of you may know as a French religious philosopher, and Christopher Jackson, an incarcerated man who is also a friend and who discovered a passion for math while in prison. And I wrote the book because so many people, including myself, have had bad experiences in mathematics. I tell some of those stories from my own experience in the book. But yet I'm one of the lucky ones who see a side of math that few people get to see, the creative side, the life-affirming side, the enchanting side of mathematics. And I think more people should see that side, and yet that's not often how it's taught. And I'm drawn to questions of the soul and the kind of questions that I know you like to explore here at Upper House. And I've often asked myself how math connects to the human soul. And the book is really a result of me exploring that question.
Great, thanks. And just to give viewers, if you haven't picked up the book, a sense, it's in 13 chapters, and each chapter is titled what you call a human desire. And so some of them are flourishing and exploration and meaning. And we'll be sort of talking about a few of those, and there's a number of more. Actually, I'll just list the rest. Flourishing, exploration, meaning, play, beauty, permanence, truth, struggle, power, justice, freedom, community, and love. And so you can get a sense even from those words, sort of how universal and how broad-ranging this discussion can go. Those are topics, those are desires, as you say, that touch every human and sort of unite us maybe as humans. Before getting into the sort of content of the book, could you say a little more about your he's listed as a co-author, Christopher Jackson, and what he brought to the project, and even in the book how you bring in his letters as well. Yeah.
So Chris's story is a redemption story. That's basically the framing of the book is that here is a story of a fellow who discovered math in prison, and as his life is being, in some sense, redeemed because of the things that the ways he's growing and learning. And there are many redemption stories in the book, but his is perhaps the most prominent. And he and I have corresponded for many years now. He's supplied letters from our correspondence that appear in between the chapters. And as you move forward through the book, you see his transformation over time through these letters, and it's really remarkable.
Yeah. I think at the end of every chapter, there's a letter by Chris, and then like a brain teaser math question. So it's a fun thing to there's a rhythm to the chapters in that way as well.
Yeah.
Go ahead.
I was just going to say one of the things that he and I correspond over many things. You talk about math, but we also talk about life and other things. But as I was writing the book, I sent him drafts of the chapters, and so some of the letters you see are kind of responses to ideas that appeared in the chapter. And then at some point I said, well, gosh, I think your letters actually capture a lot of the kinds of things that I want to communicate in the book. And so that's when we invited him on as an official contributor to the book, and he and so all these letters are actually candid letters, right? He didn't know they were going to be in a book when he was writing them, and so you sort of see a real honest reflection of him through these letters.
Yeah, that's fascinating. A very unique wrinkle to the book. Sort of sets it apart from other books in the same genre, for sure. So before getting into the details of the chapters, I think it'd be helpful just to give you a chance to define some terms. And so what do you mean by mathematics? And what do you mean by human flourishing? I know those are really big concepts, but do you have some sort of working definitions for us?
Yeah, I'll try to be as brief as possible. So it's often among mathematicians common to speak of mathematics as the science of patterns. And that, one of that's is that it pictures what it is that mathematicians do. We like looking at patterns, not just numerical patterns, but maybe patterns in nature, patterns in the kinds of things that underlie the things around us. But I like to add something to that description. I like to talk about math not just as a science, but as an art, the art of engaging the meaning of those patterns. So that's probably the quickest way I describe math: the science of patterns and the art of engaging the meaning of patterns. And I like to think of human flourishing as living life well, even in the most difficult circumstances. And perhaps it's most tightly bound for this audience to a Christian conception of joy, something that's deeper and more not just an idea of happiness. It's not just a state of mind, but the idea that you are both being and doing. You're learning to live life well, and you're helping others to do the same.
Yeah. That's great. So as I mentioned, I'm a historian. I really enjoyed reading the book as a historian, mostly for two reasons. One was to think about what a history for human flourishing would look like. Sort of, I think a lot of people can read your book and sort of read in their own disciplinary background and think, oh, something like beauty. What would a historian say about beauty? So that was one way. And another way, though, was to think about what you were actually saying about math, and thinking about how historians, how the historical discipline can intersect with that, or how other disciplines can intersect with those insights, and how those insights might be expressed differently in a different field, but actually are getting at some truth. So that's sort of how I want to approach sort of throwing in my own comments here, is just as a way to stir the pot and maybe help us sort of have a wide conversation about some of the chapter titles and some of the human desires that we're talking about. So I thought the first one we could go to is exploration, which is one of your early chapters. And I wanted to read just a very short passage from the book that gets at maybe one of the stereotypes that outsiders might have of math. And this is on page 23, and you say, exploration and understanding are at the heart of what it means to do mathematics. Unfortunately, exploration is not a word one associates with mathematics if one thinks it is just arithmetic, or something advanced and even more dreary that was discovered and settled long ago. And so there you're trying to push back against a very popular conception maybe of math as sort of rote memorization or something like that. So can you give us a sense of how you understand exploration being at the center of math?
Sure, yeah. I mean, I guess I think of exploration as beginning with a question. What if, right? If you go on a hike, you might ask, what if I take this path instead of that one? And it's the same way in math, right? When somebody teaches me an idea, I naturally ask, what else can I learn from this idea? And so I'll give you an example. My PhD advisor is famous for studying the question, how long does it take to mix a deck of cards when you shuffle a deck? And, that's a question that intersects the things we do every day, like play with a deck of cards. The question he asked was, well, how many shuffles, if you take a riffle shuffle and you shuffle the deck the way people normally do, they sort of interleave the deck using a riffle riffling the deck, then you could ask, like, how many shuffles does it take to mix a deck? Like, is a deck well mixed after 1 or 2 shuffles? And most people, if you think about this a little bit and you just study the cards, you realize the answer is no, not 2 shuffles. And so here's a question that had not been answered until only recently, until he actually settled the question that it takes 7 shuffles to mix a deck of cards. So that's a mathematical idea. It sort of shows that math is alive, and it's not just a bunch of things that were discovered, centuries ago and settled centuries ago. We still have open questions in mathematics. And the other thing that's interesting here is that once you ask that question, it leads to lots of other questions, right? You might ask, well, gosh, what about other kinds of shuffling? Right? If I mix a deck using an overhand shuffle, which is another popular way of shuffling a deck of cards, is that better or worse? And it turns out it's a lot worse. And this is a question that's only been settled relatively recently. And I'm talking, the last 30 years. And in geologic time, it's very recent. in human history, it's very recent, right? And so this is what exploration is, right? If I show you a new way to multiply numbers in your head, then when you learn that, you're not just satisfied with learning that fact, right? You're like, well, gosh, what if I want to do something else? And I could tell you actually, let's do this. I'll tell you a trick for multiplying a 2-digit number by 11 in your head quickly. Do you want to see?
Yes, please.
Okay, good. Give me a 2-digit number.
22. No, maybe
okay,
that's
22.
Too hard.
No, it's fine.
Okay.
So I'm going to multiply 22 by 11, and it turns out there's a very nice pattern. You just take the 2 digits and you add them together, and you put that number in between. So 2 and 2 plus 2 is 4. We'll put the 4 in between. The 22 times 11 is 242. Okay, so that's a cool, it's a cool pattern. It's interesting. Yeah. But, somebody who's mathematically trained would ask, why is that pattern hold? And does it work for other numbers? Like, what happens if you give me another 2-digit number, like 35? Sure enough, if you do 35 times 11, you'll realize it's 385. You're like, oh, okay, this pattern holds. Why does this pattern hold? And so the explorer side would say, gosh, what if I want to multiply a 3-digit number by 11? What's the pattern? Or if I want to multiply a 2-digit number by 111, is there a similar pattern? This is the kind of thing that explorer engages in.
Yeah, that's fascinating. You talking about cards reminded me of one of the just sort of facts in your book about how many potential combinations there are in a 52-card deck. And how that number is more than the stars in the universe, more than really, basically the takeaway I had was like every single time anyone ever shuffles a deck, it's probably a unique 52-card arrangement. And that's just, there's something oddly inspiring about that. That sort of every Casino hall has, unique shuffling every time.
It's mind-blowing. Right?
Yeah, it is.
And that actually points out another thing about math is it's sort of meaningless unless you place it in context in some way, right? We could talk about the very large number, the 10 to 68 combinations, but that has no meaning unless you place it in some kind of context. Like, whoa, like that's so large that anytime you shuffle a deck of cards, you're making history, right? Like that's the first time that configuration has ever been seen, most likely.
Right. Yeah, exactly. Well, thanks, Francis. Thinking about this stereotype, though, of math, it made me think about how history is often understood by outsiders, that some might define it as just a sort of chronicling of facts, of just arranging names and dates, and it made, sort of thinking through this, reminded me of a famous historian named E.H. Carr from the 20th century who wrote a book called What is History? It was from the 1960s, where he was trying to do some of the public relations work that you're doing with math. And he had this line that I think you could fit in historians or mathematicians as well. This is E.H. Carr. He said, "To praise a historian for his accuracy is like praising an architect for using well-seasoned timber, or properly mixed concrete in his building. And we might say a mathematician using her multiplication tables or something like that. And he says, it is a necessary condition of his work, but not his essential function. And that's, of course, the underlying a lot of disciplines is there is of course, a basic a craft, a basic need for that, sometimes memorization, but other times just mastery of very basic skills. But that is in order to get to much deeper truths, or in another way to think about this, at least historians talk about sort of the difference between historical knowledge and historical understanding, and that knowledge you can accumulate a lot of knowledge and not have a lot of understanding of or appreciation of the knowledge. So, I mean, you've talked about it a little, but do you have anything else to say about sort of the relationship between the facts of math and the open exploration of math? And I think you just had a great example there, but how might you say that to non-mathematicians?
Yeah, I mean, I love the example that you brought up. I mean, I think this points out that there's a tendency in many subjects to be reductionist, isn't there, right? History isn't just a bunch of facts. Language acquisition isn't just about grammar, right?
Right.
Chemistry is not just about memorizing a periodic table, right? And as a historian, your exploration might lead you to ask, what trends in history can I uncover, right? In language, exploration might lead you to write poetry, right? And in chemistry, you might ask, what novel molecules can we build, and what can we do with them, right? And so, one of the best ways that we can, all of us, not just mathematicians, can encounter this aspect of math, I think, is in everyday things you're doing, like playing games of strategy, right? Each time you play a game, you're engaging in strategic thinking. You have to ask, if I do this, then what's going to happen? Or maybe learning to appreciate puzzles. This is another way that you can bring this exploration side into the way we do math and think about math. That's
great. Yeah, so let's turn to another of your chapters, beauty. And beauty is something we often associate with the discipline of art. And in fact, you make that connection right off the bat in the chapter, where you quote Olga Towsky-Todd, who says, the yearning for and the satisfaction gained from mathematical insight brings the subject near to art. And so right there, that's that connection between math and art and beauty. And I wonder if that connection might be counterintuitive to some people. And just one really simple and spatial metaphor of that is here at UW. The building that houses the art department is quite far away from the building that houses the math department. And there are many buildings in between, including the humanities building and an administration building and the music school building. And that might be just a spatial metaphor of some of the distance that people might have to make to connect math to beauty. So how should we think about this connection between math and beauty? And you talk particularly about types of beauty. You talk about sensory beauty and wondrous beauty, insightful beauty, and transcendent beauty. So you don't have to pick up all of those, but those are the different ways you're talking about beauty. How do you see that connection working? Sure.
Yeah, I thought you might ask about beauty. So I have some slides here that I'm going to share that might help illuminate what I mean when I think about beauty.
Yeah.
One of the things that often happens when you encounter something beautiful is you stop and you reflect, right? That's the like this picture, which is from my book. Is a picture of a figure that is standing before a mathematical pattern and just stopping to reflect. That's what I mean by sensory beauty. It's just the idea that we that we stop and ask, hey, what's going on? Why is this thing striking me the way that it's striking me? But then you might move on from there to begin to ask questions like, why is this?
Francis, could you share your screen?
What's going on in this map? Oh yeah, did I not share the screen? Let me see.
Yeah.
I think there's it says here that I am sharing the screen, so I wonder if that's a issue with is Dan Someone in the background able to put the screen share up? I'll stop sharing. I'll try sharing again.
Okay, sounds good.
It's all right if we don't have a, if it doesn't end up being possible to share. There, I've shared
Here we
it.
go.
So let's see. Here we go. Okay, yeah.
You're good.
So
Sorry
here's
for interrupting you.
a figure from.
Yeah.
No problem. This is
Yeah.
a figure from my book.
Yeah.
A figure standing for a mathematical pattern. In this case, it looks like stained glass windows, and that was intentional, right? So there's this sense of awe at the mystery of beauty, and the same thing happens in mathematical beauty as well. You have a sense of awe. So here's another potential example. Let me see here. My computer is being finicky right now. I wonder. Oh, actually, I think I unshared the screen. That's probably the problem. Play slideshow window. Try that again. Okay, so I think you can still see this here. And then not. Hang on. Play slideshow window. Sorry, I had to go. It was because I was going the wrong direction. Here are some other patterns that evoke a sense of mystery and awe. If we the screen share here, oh, the share screen is off. Hang on, let me try again. Here we go. A couple of other other patterns to look at here. So one of the things that often happens is you notice a pattern and then you appreciate it for, like, you know, there's sort of some insight that happens. And this is kind of the feeling like of insightful beauties, when you sort of see, whoa, something amazing, I just noticed something. So in the upper right corner here, you see the square. And if you see the colors of the stripes of different colors, you see that basically we have a square that's composed of a bunch of stripes. And the stripes have 1, 3, 5, 7, and 9 squares in them. And so what does this picture represent? It actually shows you why, if you sum up odd numbers, you always get a square number, right? 1 plus 3 plus 5 squares is a 3 by 3 box. So it's going to be 3 squared. But 1 plus 3 plus 5 plus 7 plus 9 is 5 squared. And once you see this pattern, you're like, oh, hey, I sort of understand why it is that when I add up a bunch of odd numbers, I get a square number. That's kind of like the awe, the wonder, the insightful beauty that you get from a mathematical idea. Mm-hmm. In the bottom left, there's a picture of a representation of why it is that the fundamental, that the Pythagorean theorem is true. Some of us remember this from high school geometry, that if you have a right triangle and you add if you look at the side lengths, their squares sum to the square of the hypotenuse, the long side. And so this picture actually represents that and helps you see why it's true. Like, many of us sort of learn that and think, oh, did somebody just make that up? Did somebody just declare that that's true? And the answer is no, it's built into the fabric of how the universe works, right? Like, it has to be true, right? And so this picture shows you why it's true, because if you look at the two squares, they're the same size, and so you have to. And then if you look at the triangles, the 4 triangles in each picture are also the same area. So the blue area has to be the same as the sum of the 2 green areas. And if you think a little bit about it, the small square is, if you like, the one side length of the triangle squared. The bigger rectangle is the other side length squared, and the blue square is the hypotenuse squared. And so then you're like, okay, I see why this is true. That's kind of what happens with of insightful beauty, is you're like, oh, I see, I understand. And so maybe this points to what I like to call transcendent beauty, which is the idea that, like, that when you see a bunch of different, the same idea pop up in many different places, you begin to think you're accessing something fundamental about the nature of the universe. That's the transcendent feeling that people get.
Yeah. That's great. Thanks for sharing those, Francis. I reflect on a difference here with history and math, that it seems like with math, there's just, if you can grasp a certain number of basic concepts, you can start playing in a way with sort of universal laws, and sort of uncovering them, and it's a little different than history, for sure, in the sense that history is often driven by sort of archival research that you don't know what you're going to find until you go find it, and then some of that work, of that integrative work, happens. But it is a different process, and thanks for walking us through some of that. That's actually one thing the book does very well. A number of the chapters, there's a lot of images for one thing, but there's also a lot of walking through some of these ways where, and you give us all the tools we need as we're reading to sort of grasp at least the significance of what you're showing, and that's particularly true in the beauty chapter. So here I just want to take a quick break and do a sort of quick questions, fun little rapid round with Francis, just to break it up before we do a couple more chapters, and then get some audience questions as well. So Francis doesn't know these questions. They're supposed to be fun. Nothing. Just sort of say the first thing that comes to mind, I guess. You don't need to sweat over the answers here. But this also will hopefully help round you out as an author and as a person. So first one, do you have a favorite piece of pop culture?
Favorite piece of pop culture? Yeah, it's a great question. How about Lord of the Rings?
Okay, that's a tried and true one for sure. What's your favorite class to teach at Harvey Mudd?
I love teaching multivariable calculus because you get to play with drawing lots of pretty pictures in 3 dimensions. For
those of us who don't know even what multivariable calculus is that like an advanced class? Is that an intro class? Is it somewhere in the middle?
Oh, yeah. Okay, so yeah, good. So like, for instance, as late in high school or early in college. Multivariable calculus is sort of the next step up, where you look at change in 3 dimensions. It's often at near the set of intro courses you would take if you went on in engineering or in mathematics or in physics. At the upper division level, one class I love teaching is this class called topology, which is the study of shapes. And there's hardly any numbers in it at all. It's basically thinking about stretching, deforming shapes. And so that's also another one I like, because you play with a lot of pretty pictures.
Yeah, fascinating. Okay, this one may resonate differently with different disciplines, but is there in the last 50 years, what's the sort of most significant paper in math that's come out? Like, has there been sort of a defining paper in your field, or in history it'd be a book usually? Most of the big contributions come in book form, but is there something sort of pre and post that mathematicians in 2021 talk about?
Yeah, well, a lot of it really depends on the sub area of math that you're in, but I guess some would point to the proof of Fermat's last theorem, which is this question about numbers that remained unsettled for more than 400 years. And that's often lauded as a huge historic achievement.
Yeah, that's one thing. You mentioned a few in the book, just how really, really long questions that have been around a very long time are still being answered for the first time in the 21st century, which is maybe that's another sort of misconception, is that we know all the math and now we're just sort of passing it down generation to generation.
Well, part of it is definitely.
Yeah, that makes total sense. Okay, moving on. Is there an up-and-coming mathematician that, and maybe this is I was looking at the Mathematics Association of America website, and just looking at sort of the books. Your book won the Euler Prize for last year, and looking at some of the other books, which are more in the sort of popularization of or math for the public type domain. Is there a younger mathematician that's really doing good work in that space that you'd highlight?
Yeah, I think my internet connection cut off when you said, "Is there an up-and-coming mathematician that blank?" So if you could fill in the second part.
Sure. Just is there an up-and-coming mathematician that's doing good work, sort of translating math for the public, like you do?
Oh, I guess one name is Eugenia Cheng. She's written lots of books that are related to helping the public understand what math is.
Great.
In a maybe two. Another one that's maybe not up and coming is Jordan Ellenberg, but he's written a book about mathematical thinking.
Great, thanks for that. And last question on this rapid round. What would you give what advice would you give to an undergrad student who comes to your office and is considering majoring in math? Do you have any sort of tried and true advice you give for weighing, should I major in math or not?
Oh yeah, I think anybody who has a desire to major in math should do it, and often do it in conjunction with another major, because especially if it's a scientific major, because there's often a lot of math that you'll have to take anyways, and they can sort of double duty. But yeah, I encourage anybody who's interested to do it, and to not be afraid of or be intimidated by either the mathematics or the people in it, because as I say a lot in the book, a lot of what math is learning how to struggle with hard problems, and not necessarily about getting answers.
Yeah. Great. Well, let's jump back in just to a couple more of the chapters. I should remind audience members, if you have any questions that has been provoked by what we've talked about so far, or as we're talking, please leave them in the chat. I see a few people have already started to do that. I wanted to move to maybe one of the more unexpected chapter titles, at least for me, coming in as a non-mathematician, which is community. You have beautiful reflections in that chapter on what it means to do math in community, and also related to a few of the other chapters sort of around it, about how that community can be hard to get into, and how there's a hierarchy to the community, and how you sort of have a passion to widen that community as much as possible. So can you tell us what you mean by mathematical community? And then we'll jump into a few other things around that. But what's your working definition of community, and how do you understand sort of math in relation to community?
Yeah, I mean, I think math, when I think about community, I think about people gathering together over some mathematical activity. For instance, it could be whether it's playing a game. That's one way to engage in mathematical community. But it could also mean, doing research together at the higher levels. And so anytime we share an interest in some idea, a mathematical idea, that's sort of creating a community.
Yeah, and so can you talk a little about, I know this is sort of a newer sort of front on math, but talk about sort of, I think what you call at one point math justice, but also the ways that math has historically been segmented off from certain parts of society, and sort of culturally more adaptable to other parts of society, and how particularly mathematicians today are thinking about those issues and addressing them.
Yeah, that's a great question. I mean, I think people often have this view of mathematics that it is something that only some people do, and that I think is a very harmful idea. First of all, because all of us are mathematical thinkers, and we do math all the time without perhaps realizing that we're doing it. And also because of the idea that a lot of the new technologies that are shaping the way that we live are mathematical, and when you are limiting others from experiencing mathematical wonder and joy, or when you limit yourself, or maybe you encounter obstacles that other people placed in your path, you're actually in some sense being harmed because you're not able to participate in some of the things that actually help people flourish today. And so this is part of the argument of the book, is broadening the purpose of why we do math, right? Math isn't just for me to get a credential. It's not just to get a career, to be in a career. It's not just to get a good job. But it's actually to help people flourish, which means appreciating seeing life differently, seeing oneself differently, being able to see the unseen. That's one way I often talk about mathematics. It's seeing the unseen patterns of the world, and we would all do better if we could help one another do that. And so, for the professional mathematician, it's often like a mark of privilege to be able to say, I have a PhD in math, listen to me, I'm wonderful, right? Mm-hmm. And so there's maybe a barrier often that people who do math well often see it as a way to distinguish themselves, right? There's a certain elitism. And I want us to sort of move away from that, because I'd like all of us to be able to experience the benefits of mathematics and its power to help people flourish.
Yeah. Yeah, and I just think about too how there's so many ways that we probably we might think about them, but that you can engage in math, and even in community, down to Sudoku puzzles and other things that are really actually exercising mathematical thinking and skills. And so there's a lot of, if you sort of open your eyes to it, there's a lot of accessibility into realizing how many ways mathematical thinking actually intersects with most people's lives on a daily basis. Yeah. Okay, let's turn to truth. And in your chapter on truth, you delineate some of the virtues that mathematics at its best instills in the people who are searching for truth through math. You talk about the thirst for deep knowledge, thinking for oneself, circumspection, intellectual humility, and others. So if you can just walk us through part of that chapter, how do you see these virtues embodied in mathematical truth? And how do you see them extending sort of more universally?
Yeah. Yeah, I mean, I think that in many ways was one of the hardest chapters to write, partly because of our own cultural and political moment. And we see, of course, a lot of propagated, perhaps unwittingly, by people who aren't bothering to think for themselves, right? Like there's sort of the sense that often we just take truth on authority, and if it's somebody I trust, then I believe it's true. And math is very different, right? Like when I see a statement like the Pythagorean theorem, as a mathematical thinker, I don't just say, well, somebody just said it was true. It's not just some invention that somebody made. This is actually fundamental to the fabric of the way things work in the universe, right? And so part of what happens as a mathematical thinker, if you are thinking, learning to reason and think, is you want to understand every truth for yourself. And that's really freeing in many ways. It enables us to actually to say, okay, well, maybe, if I see some idea out in the world, it helps me evaluate, okay, well, how does this connect to the things I already know, right? Like if I learn about gravity waves, it makes me think, well, how does this connect to the high school geometry that I learned, right? Like somehow this beautiful idea that somehow you can study black holes that collided, millions and billions of years ago using the geometry of the universe is kind of profound and amazing. That's like one of the biggest ideas in physics and astronomy in the last century, the ability that we could do this, right? And that's all mathematical, right? You have some way of appreciating that. But it also allows us to say, hey, like if we have a pandemic that's spreading, if you're mathematically trained, you begin to realize, yeah, this thing can actually take off with exponential growth. And people, it's going to be a lot more dangerous before you realize that it is dangerous because of exponential growth, right? So there's this ability that in its best forms, mathematics trains us to not just take things on authority, but to think for ourselves. And that's that's part of what I sort of have to unpack in the chapter.
Yeah.
And maybe it's complicated also by the fact that, I don't know if people, believe that in objective truth. And certainly there are, and I try to nuance that discussion a little bit, as you maybe saw in the book. Like I have a very simple definition of truth, and I also realize that truth can be complex and there are many sides. And part of what I'm saying in the book is we, as mathematical thinkers, get trained to look at multiple sides of an argument.
Yeah, that's great. And that actually, so one of the quotes from your book that stuck out to me was on page 112. And you talk about, it's a very optimistic chapter, the truth chapter, I think, even though it's framed in sort of there are challenges to this, particularly in the 21st century. But you talk about the noble hope that we can know the whole truth, even of messy, complex truths, and that some things are absolutely fundamentally true, so that we can have confidence in truth to combat those who wield lies brazenly. And it reminded me, going back to my historian roots, of a pretty well-known book, particularly among American historians, called That Noble Dream. So that's one thing that rang the bell, was you talk about noble hope. This book was called That Noble Dream, The Objectivity Question, and the American Historical Profession. It's from the 1980s. It's by a historian named Peter Novick, who is no longer with us. But that's a history of the idea of objective truth in the field of American history over the 19th and 20th centuries. And he ends that book in the 1980s with a chapter called There Is No King in Israel, which is a reference to the book of Judges, and the idea that basically that the dream of that noble dream of objectivity had sort of fallen apart in the historical profession. And for a variety of reasons, and the conclusion wasn't that there is no such thing as truth. It was more of a critique of the idea of objective truth. And I think that type of complicating the understanding of truth has happened in a lot of fields in the last 30 years, 40 years. I wonder, just give us an insight, is there a similar type of conversation in mathematics, or has that type of, and I'm giving you sort of the surface level version of the story in math, and there's a variety of reasons why people question objectivity, some of them actually very good reasons. But I'm wondering just if that same type of conversation is happening in mathematics, or if that's sort of not really part of the mix.
Yeah, certainly. There is a conversation that's going on in math around that, and that's, I think, the idea of the objectivity of math, and often I think it's very easy for people to understand the nature of that conversation. So when people say that it's objective, they're not saying that if I add 5 plus 5, I'm not going to get 10. I think what they're trying to emphasize is that because mathematics is embedded in culture, often the way that we understand and interpret mathematics is laced with, is sort of intertwined with, inextricably with the culture that we have around how we do mathematics. And so one of the ways that you might be concerned about the way math is sometimes used, it's often used to beat people over the head, right? Like to be able to say, hey, the numbers just show this or that, right? Without actually thinking about the people behind those numbers, and without actually questioning some of the assumptions that you come with when you start trying to objectify everything using mathematical language. And so there's that. On the other hand, of course, no one's questioning the fact that, like, it's somehow wonderful, beautiful, and amazing that, different cultures over the centuries have rediscovered the Pythagorean theorem, right? Like that sort of points to the universal nature of certain kinds of mathematical truths. So there is kind of this interplay that in conversation that's going on in math, and that's often, I think, misunderstood right now by people who want to who are maybe not clued into that conversation.
Yeah, makes total sense. Okay, let's end on your last desire that you discussed, which is love. And I can recall in C.S. Lewis's book, The Four Loves, how he talks about agape love as sort of the as unconditional love, as best expressed through Christ's love for humanity and his sacrifice. And you talk in your chapter about unconditional love as well. So I just wanted to give you the space here to talk about the importance of love when thinking about mathematics, and how do you see math as an entryway into love?
It's perhaps maybe most surprising chapter title in the book. I think some people are surprised to see that. But if you think a bit about how it is that we love people, what does that mean? It means in some ways seeing the best possibilities in people, and so this chapter is really not talking about the love of math, which is often what you might think if you're just scanning the title. We're not talking about loving math. I'm actually talking about loving people. And I'm talking about looking at people with different eyes, right? So the quote that I like to pull out of the book is that every being cries out silently to be read differently. And she means to be judged differently. And in many ways, this is what happens with people in math, is they're discouraged from doing math because others don't believe that they have mathematical potential. We say some people are math people and other people aren't. That tends to marginalize and exclude people who might otherwise be actually enjoy doing math and be good at it, right? So part of what it means to love people is actually to believe that everybody is worthy of the beauty and joy that come from understanding. That's really what that chapter is about.
Yeah, great, thanks. And that's a great, you actually end with an epilogue that brings Chris back into the story, but it was a very interesting way to end the book. Actually, this just came to me. Did you organize the chapters with any particular logic behind it? Or yeah, I'm sure you did. I'm going to assume, but what was it?
Yeah. Well, I mean, some of it was, so I knew I wanted to start with exploration because that's sort of fundamental through the idea that runs throughout the rest of the book in framing who we are as explorers. And I knew I needed to end with love because it's perhaps the most surprising and challenging chapter. It wasn't an accident that love was the 13th chapter in the book. And then I needed a bunch of other chapters, figure out how to organize the other chapters. And some people have asked, like, are there chapters you left out? And the answer is yes. There are actually many ideas that I thought could be chapters, and I didn't put them in. I think the way you see the progression is that the first chapters are about beauty and truth. These are probably chapter ideas that most people would in mathematics would not question as mathematical things, passions, desires that drew people to math. The later chapters get into some of the more difficult questions related to mathematics and mathematical culture. And it's really a call to change the way math is being practiced these days.
Yeah.
And so that's, you start with some of the easier stuff and you move to some of the harder stuff. That was part of the progression.
Yeah, that makes total sense. Sort of shared common ground, and then moving into your specific concerns. That makes total sense. Well, thanks, Francis, for the conversation so far. I want to turn to asking some pre-submitted questions. I'm going to scroll through the chat here too and see what people are asking. But these are some of the questions that came early on when people were registering. And so Eric asks, what have been some of the most effective ways of imparting to your students a desire and motivation to learn mathematics? So what are some of the most effective ways you've imparted to students your love of math?
Yeah. Often in lower division courses where I encounter lots of students who are taking math because it's a requirement, and not necessarily there because they've seen the wonder and the beauty of mathematical thinking. I'd like to start off my classes just showing them a beautiful idea. I call these math fun facts, and it's a 5-minute digression, often from the topic at hand, but it sort of opens up people to a beautiful idea that causes them to sort of ask, "Oh, why?" or "That's kind of cool," or that, and that's I think that's been pretty effective in helping people sort of get away from the performance side of mathematics. Like, not everything you need to learn in math has to be about performance. It can be also about wonder and joy.
That's great. That actually leads into another question that Amy in the chat has asked. She says she works with homeschooling families, and she often hears from them, "Why do I need to teach algebra or beyond algebra?" And these are coming from generally very pragmatic mindsets. How would you answer that question?
Yeah, that's a great question, and this is part of gets at the question all of us have asked at some point, which is, why do I need to learn this stuff? Yeah. And the answer that we often hear from our teachers is, because you'll need to know it later. And part of what I'm saying in the book is that, first of all, that's not necessarily true. Like, most people who learn calculus never use it, right? Maybe if you do some kind of science engineering, you. But part of the reason we learn calculus is that it is amazing. It's an amazing triumph of the human mind that we can take a simple idea, the idea that you can cut things up into little pieces and put them back together again, to planetary motion or things that are going on in the world, the dynamics of the world. It's an amazing idea that you can do this. And so part of why we learn, let's say, I'll come to algebra in just a second. This is like an achievement. It's like, people going to look at the Mona Lisa or whatever it is, or Michelangelo, like, it's like saying, look, we can appreciate some of the powerful ways that simple ideas have had profound consequences on the future of humankind. Okay, so that's one way to frame calculus. But it's calculus and algebra are both exercises in learning how to think, right? We all need to know how to think. So, for instance, when an employer decides they want to hire a math major, they don't hire a math major because they know how to factor a quadratic formula. They hire a math major because a mathematically trained person knows how to sit and struggle with a problem that doesn't have an easy solution, right? This is what an employer is looking for. Do they have persistence? Do they have curiosity? Do they have all these other virtues that maybe you think of as soft skills? I like to call them virtues, right? Like that are built by a mathematical education. So part of why we learn algebra is there is the appreciation side of algebra, which is algebra is basically trying to solve a bunch of problems all at once, right? I don't want to have to derive a different formula to calculate how many calories I eat every single time I go to the refrigerator. No. I want one formula that works in a multiple, variety of situations. That's algebra for you, right? That's why we learn algebra. Yeah, I could go on, but I probably shouldn't.
No, that's great, and it reminds me again of sort of a similar conversation in history about sort of why major in history, and I think humanities tend to get this question even more than other parts of the university. But some of the same factors come down, which is that being a historian trains you to think in a certain way and trains you to ask certain types of questions and to weigh evidence and to learn how to weigh evidence. And it's not, no one will probably ever hire you because you know a lot about the Napoleonic era or something like that, unless you're trying to be a professor in history. But there are these, and writing skills and other things that a history major gives you. And I think that's a lot of what, that can maybe be a misnomer for a lot of people outside of a university, is actually what's going on in classrooms there is of course a conveying of information, but that's you can do that sitting at home on a computer. What's really happening in the classroom often is learning how to think and learning how to struggle, another one of your terms, toward deeper insight. And so I think that's something a lot of fields share, and you'd have to make sort of the same case to the skeptical homeschool parent or the skeptical undergrad student for why they should be taking these courses.
Yeah, I actually recently had an appreciation of thinking using the thinking historically in terms of what you were describing, because I've been on this task force to try to understand the history of racial discrimination in mathematics. And one of the questions that we had to ponder in our task force as we gathered various kinds of evidence is what kinds of evidence are available to us, and why are they available to us, and what evidence is perhaps missing and inaccessible, and thinking through some of those issues. And then that was sort of an eye-opening experience for me, like, aha, really, to think historically, you have to learn how to weigh evidence and what's good evidence and what's not.
Yeah, of course. And to get back to the exploration theme, there's also, there's written evidence, which is the most common type of historical evidence. Someone wrote something down, or there's a report or something. There's an archive with a bunch of papers in it. But there are, of course, other types of evidence that historians, particularly if you get creative, can use to weigh in and try to find things that aren't there in the written record. And so there's whole books, there's whole sort of careers made on thinking through creative ways, particularly for people who did not leave archives, which is a lot of people. It turns out, even though there are a ton of archives, most of them were left by the people who could. How do you get at those stories, and how do you somehow bring those stories into the stories that we have really good records of and documentation with? So yes, you just got me going on sort of thinking historically, but yeah. Okay, so David asks, how can we democratize the use of mathematics in support of the key performance indicators of a just society? So what are some of the ways, maybe this is part of that task force too, but what are some of the ways that you've been thinking about democratizing mathematics in order to sort of address injustice?
Yeah, I'm not exactly sure what the questioner was asking about, the key indicators of just society, but I assume he means in terms of having an equitable society where people have access to mathematics regardless of whether you live in a small town or whether you are in poverty. Yeah, I mean, I think one of the things, there's a huge movement in mathematics, especially at the K through 12 levels, to try to improve access to good quality mathematics education. A lot of people are thinking about it. It's a hard problem to solve because when you're a teacher, you often are you're called on to do lots of things that are very hard, and you're not paid well for it. And there's also a lot of inertia that's present in the educational system itself, in people wanting to teach the ways that they've been learning mathematics, which is not always equitable either. And so, yeah, so I guess the question was how can you do more of that? I guess one thing I would say is to try to tap into what's already being done. People are thinking about what does it mean to teach math in a way that is actually inclusive and recognizes the challenges and barriers that some people face, especially if you come from an historically underrepresented background. So there's a lot of good thinking about how you teach and teach well to all students rather than just teaching. The traditional model is teacher talks and students take notes and listen. And, in college, that's certainly the way the model is. And the lower grades, it's, drill your math facts, right? But a lot of these practices, they're actually cultural practices that are not as welcoming to people who, for instance, don't necessarily experience some of the freedoms of mathematics, right? Like we know that great teachers actually have classrooms where students actually feel like they're participating in mathematics and learning mathematics and enjoying it, actually making creative choices. But we also know that in other classrooms, mathematics feels like a prison, right? Mathematics feels like you are just forcing me to do a bunch of things that I don't like. and sometimes inequitably, right? Sometimes teachers inadvertently have biases that they propagate in their classrooms that can be unwelcoming to others. And so thinking through some of those things is, I think, a huge part of what we need to do moving forward in the math community. But I want to say a lot's being done in the K through 12 level. I wish more were being done at the college level.
Thank you. Nicole asks, what sort of practical skills can a math teacher gain to help sharpen her skills with the various techniques required to teach to the standards? But those techniques are not familiar to what maybe they were trained in. So if you were to advise sort of how can math teachers sort of keep updated, I guess, in their field, what would you say?
The first thing I would say to administrators, if you are an administrator of any kind, is to try to provide professional development funds to allow teachers to go to conferences or to learn some of to get retrained in some of the more inclusive ways of teaching and some of the new ways of thinking about the standards. And that, of course, just takes resources. But on a personal level, if you're one of these teachers, I would say there's a lot of resources that are now available online by following certain, YouTube channels or Twitter accounts. There's actually a very friendly community online where you can learn a lot of cool ideas. And I would say push yourself in some ways to watch videos that may at first make sense. In fact, this is what you get used to doing in mathematics. Like when I watch a math video, there's a lot of it I don't necessarily understand. But part of what I'm doing is sort of making those connections. In that way, it's like learning a new language, like listening that you can latch onto. And it may help you sort of get a sense of what are the big questions that sort of motivate people to think it mathematically, and how can you bring those in? That's what I probably would encourage people to do. Puzzle books are another way to begin to think about math and bringing that into wonder and joy in as well.
Great. Okay, Phoebe asks in the chat, I work at a learning lab where we look at how children understand fractions and the equal sign. A lot of what we think about is if these are intrinsic. What do you think about the idea of innate math skills?
Let me turn the question around and ask, what do we think about innate language skills? Now, for instance, some people are math people and some people aren't. Are we saying, would we say the same thing, like some babies are language people and some babies aren't? No. Everyone learns, picks up, acquires a facility with language in different ways. And so I would think this is true that some babies or some people pick up languages faster. But being fast at picking a skill up isn't the same as being proficient and ultimately being proficient at it. So, and so coming back to math, then I would say that I reject the idea that some people are math people and some people aren't. I do think that some people will pick up mathematical ideas, have a more of a facility to pick them faster, but we have plenty of examples in mathematics, even of mathematicians who would call themselves slow to pick up things, but have been some of the most respected mathematicians in history. Even. So so I that's a long way around of answering the question. I don't subscribe to the idea of innateness as in mathematics at the level that we are discussing, which is an appreciation and understanding of mathematics to function in society. We all can do it.
Yeah, thank you. So I want to wrap up here with a few more questions that are more about, and they're sort of previewing the events we're going to have with you tomorrow and Wednesday, more about your faith and math, and so I'll ask just a few questions here, but also point people to both of those events, and I'll talk a little about them at the end of the time here. But you will be with us tomorrow at 4 p.m. Central, and then on Thursday at noon Central as well. But there's a couple questions that I've asked sort of about the intersection of math and faith. And one of them is by Phoebe. Again, it might be the same Phoebe, I'm not sure, who asked the one in the chat, but this is a pre-submitted question. And she asks, do we need more mathematicians who believe in God? And that's sort of a provocative question, but do you see faith impacting math as a field, faith in God in a field? And is that something you'd be interested in growing, or is that sort of irrelevant to the development of math as a field?
Yeah, I mean, I guess I wouldn't think of math in those terms, or faith in God in those terms. I think certainly if you are a person of faith, you can help shape the conversation around some of the you can contribute to the flourishing of the field of mathematics. You can be salt and light in that sense. You can work towards a common good, and these are all things that I think that for instance, Christians are called to do, is to work towards the common good of to seek the welfare of the city to which we've been called, to put it another way. And so, yeah, I mean, I guess I don't think that, I don't see that as a call to necessarily say that the field of math needs more people who believe in God. I would say that those people who are people of faith can bring something unique to the conversation.
Yeah, it's actually, I might have been reading into this question. In the field of history, this has been sort of an ongoing conversation, like a public conversation among some historians and some of the big names, people like George Marsden or Mark Knoll, who are sort of pretty well-known historians of religion. So they're sort of Christians who are studying the history of religion. And these scholars have taken different positions on this. George Marsden had a famous book in the 1990s called The Outrageous Idea of Christian Scholarship, where he was calling for basically a type of scholarship that only Christians could do. And there were plenty of pushback and plenty of debate on both sides on whether that's even a legitimate way of framing what a Christian brings to the table, to the sort of modern university higher education community. And so it's a live question, but that's also in a particular field. Yeah.
Yeah. No, actually, now that sparks an idea, maybe I have a better understanding of the question. I mean, it is certainly the case that there's a resonance between believers in God and those people who appreciate mathematics, even if people themselves are not people of any particular religion, or even an atheist mathematician would say, when they see something beautiful, that it's profound, right? That it's transcendent in some ways. And many people who practice mathematics are drawn to this transcendence, this beautiful idea. I sort of get at that in the chapter on permanence as well, which is another way of speaking about eternal truths. And so having that appreciation is really, in many ways, a spiritual longing. Whether or not you would call it spiritual, or whether or not you're a person of any particular religious stripe. And so, when a mathematician talks about, about infinity, religious people often talk about God's being infinite as well, right? And so there's a certain consonance there. And as a person of faith, a person who does math, when a religious person talks about the infinitude of God, I had a deeper appreciation of what that means, because
Yeah.
I understand how interesting and rich and complex the theories around infinite sets are. And likewise, if I'm a person of faith, then when I hear about the theories of infinity or see anything transcendent, maybe the only difference between me and an atheist mathematician is that I would point that to the work of an eternal creator.
Yeah, that actually dovetails with a question that just came in from Susie. How do you experience God as you think about math? Do you have any reflections on that? Can you even put it into words, I guess? But how do you experience God when you think about math?
Yeah, I mean, I think one rich way is that in some sense, when I see the wonder and the mystery that's brought about when I study mathematics,
Yeah.
I feel like I'm getting a glimpse into God's character in some ways, in designing a rich and beautiful mathematical world.
Yeah.
And so in some ways, doing work is a form of worship for me in some sense. And so, it's a question I actually wrestled with, and maybe I'll talk more about these in my next couple of events. But in some ways, this is sort of the big question that I asked myself. When I came to faith in college, I didn't grow up in a Christian household, but I came to faith in college. I sort of faced a crisis of, well, okay, am I going to continue to move down the mathematical path, or am I going to do what some people might call more Christian work, right? Like serving the poor and in another country or something like that. So this is certainly a question I wrestled with, and now I think I have an appreciation, understanding that part of the work that I feel that God has called me to do means doing mathematical work, appreciating that awe and the wonder as a form of worship, and helping others actually appreciate some of those beauties as well.
Yeah, yeah. Okay, last question here. This is from a different David, I think, from the earlier one. But what has helped you most flourish as an academic who's a Christian? Is there something you could point to sort of returning to the title of your book, Human Flourishing? What has helped you most flourish as a scholar and an academic?
Yeah. Yeah, I mean, I would have to say community of people who are both academics and also people of faith. I think that was a question, right? The question was as a person, both a Christian and as an academic.
That's right.
Yeah, it's helpful. Yeah, so I mean, in my own institution, there are people who I often talk to and pray together with. I have a good friend who is in another field who I meet regularly to pray over our lives, and that some of those include academic concerns as well. I think those have been probably the most helpful experiences for me to both flourish as a person who is trying to be faithful to what God has called me to do, while also being a good steward of the gifts and the resources that I've been given.
That's great. Well, thank you, Francis. We are coming to a close here, and I do want to remind people to pick up the book if you haven't, Mathematics for Human Flourishing, Yale Press from last year. It's quite affordable for an academic press book. If you go onto Amazon, I think it's under $30. It might even be closer to $20.
Yeah, I think the paperback is like 15 and
15. And the paperback came out recently, right? So it's
paperback just came out. That's right.
Just came out. Yeah. So pick up the book if you haven't. It's a great read, and it's also a great book to share with people in other disciplines. If you're a mathematician, I guess it's not just for mathematicians for sure. And with that, I do want to highlight that tomorrow at 4 p.m. Central, we will be returning with Francis to talk about bridging the gap between faith and vocation. That's going to be a Zoom meeting. And so part of the intent there is that there will be more audience interaction with Francis, and the ability for Francis to actually see some of you all. And then we will be back again on Thursday for Francis's final event with us with this joint partnership on the enigma of academic success. And that will be Francis talking about his own career arc and also some of the pitfalls that people might fall into when they put too much stock in a certain type of professional success, and how we can find our dignity in other places besides our work. So please join us for both of those if those sound interesting to you. I want to thank you once again, Francis, for this conversation, and for Travis for partnering on this event.
Thank you so much.
Great.
Thank you both.
Thank you both. Thank you for tuning in, and please visit upperhouse.org or anselmhouse.org. Is it .org, Travis? .org. For more on Upper House and Anselm House. And until tomorrow, go in peace.